Hi, everybody. Testing. Yeah, there we go. Hi, everybody. Welcome to what was going to be our Astro Coffee hangout for Friday, for this Friday. However, we've got a little bit of a snag here. So, I last week we were going to do this hangout with Matt Kaplan, where we're going to talk about white dwarf stars and a fission reaction that could cause supernovae. And I'll talk a little bit more about that in just a second. But we were going to do this last week, but I was really sick. I had a really bad case of the flu, not COVID, but the flu. And so I had to reschedule, and we rescheduled it for today. And unfortunately, Matt forgot to take into account the time difference. He's at Illinois State University, which is on Central Time, an hour behind me, and he could not make it. He's double booked. So what we're going to do is do it again next Friday, this exact time. But since I was all dressed up and ready to go, I'm sitting here, I've got all my camera stuff queued up. I thought I would go online and tell you guys this, so that instead of just not doing the stream, I thought I would tell you guys that we're going to be doing this exact stream next Friday, same time. But just not today because he's double booked. And so I thought we could just, I don't know, spend a little bit of time together. I'm streaming on YouTube, Twitch, and I think Twitter. I don't know. I mean, Twitter was Periscope, and Periscope got shut down. Anyway, I've turned it on. Maybe I'm going there. Who knows? It's just going to the ether. I was going to do LinkedIn, but decided against it since this is just an informal chat all of a sudden instead of what we had planned to do. So my apologies. Just a scheduling mix up. Mac will be here next week and we'll do this then. In the meantime, I have you guys here, and I'm monitoring the chat on all of the things. So Big Norge, hi, it's good to see you, man. I haven't talked to you in a while. And Launchpad Astronomy here. Christian is here. So thank you guys for showing up. And I know I had a hot mic. I wasn't saying anything, but I figured, what the heck? I better go ahead and turn it down. So I did. But thanks for letting me know, just in case I didn't incriminate myself in this whole thing. So thank you guys for your patience on this. And while we're here, if you want to spend a little bit of time, since we're all here, you can ask some questions in the chat. I've got the chat going. As well, although it doesn't. Yeah, I think it might show up here if you guys chat on that. I'm not sure. And I'll just give you a brief outline of what we were going to talk about, and maybe we'll talk about a little bit of new stuff, because we had some stuff happen this morning. SpaceX did it again. More astronauts on a reusable rocket on their way to the space shuttle. The space station. And also, Russia decides that by 2025, they're not going to go to the ISS anymore. They're going to build their own space station. That's concerning. And then what else happened? Of course, we saw a helicopter fly on Mars. No big whoop, really. Just flying around on Mars now. That's what we do because we can. So congrats to NASA and Ingenuity for flying up and down in the third dimension on Mars. We don't have to worry so much about driving around anymore. This is amazing. Now, I was talking about this with on T Cubed, on Tony's Twitch Tuesday, with my group, my community there. And I was asking them, I got to thinking about the advantage of having Ingenuity flying on the surface of Mars versus what we can see from the orbit, like from the MRO and those kinds of things. And I was hard pressed to come up with a reason why flying is a good idea on Mars, given all the technical challenges. We got the resolution capability from orbit to orbit to see things less than 1/3 of a meter per pixel. So we've got high resolution orbiters around Mars that can image to within 1/3 of a meter. So why do we need? What would a quadcopter get us right on Mars? And I couldn't come up with anything. But then Peter pointed out, well, these quadcopters can fly in caves, and they can go places we cannot see from orbit. So, well, that was a great idea. That was the one thing I couldn't think that we could use these for. So congrats NASA. You've done it again. JPL, you guys are rock stars, man. You get the things that you guys pull off. So I was very amazed to see that. Of course, the launch this morning was a little bit before my time. I am not a morning person. So no, I did not get up to watch the launch at 5:45 this morning, but it went off okay. And the problem with my going to launches is that it's about an hour away. And whenever there's a crew launch going on, it's insane. It's absolutely crazy. And over in Titusville, where I usually go, there's a lot of little pullovers right off of the side of US 1. And so I tend to try to find my little niche there. But whenever there is um, a crude launch, all bets are off. It doesn't matter what time of day it is; it gets super crowded. So I tend to stay away from all that stuff. Okay, so let me just give you a brief summary of what we were going to talk about today. And if you've got some questions, man, put them on the chat here, and we'll talk about them. Some people hate the chat overlay, so let me get rid of that. So my guest, Matt Kaplan, from the Illinois State University, studies white dwarf stars. We did a hangout a few months ago, last year, on black dwarfs, right? What were black dwarf supernovae and things like this. So he studies white dwarf stars. And for those of you who don't know, a white dwarf is a stellar remnant that is left over from a star that's roughly about the size of our sun, can go up to about 10 times the size of our sun. When they die, when those stars die, in roughly that stellar mass range, they leave behind a white dwarf star, which is what's called an electron degenerate core. It has been compacted so tightly, the core has been, after fusion has stopped, it has compacted itself so tightly that the electrons are now holding the star up from collapsing any further. The repulsive force of all those electrons in the individual atoms are holding itself up. And there's also other heavy elements that are associated with this that have burned throughout the star's lifetime. And white dwarfs, those heavy elements that are in them, in the cores, or in the bodies of those stars, start to decompose and start to fall apart. And Matt got to thinking about uranium, which is one of the heaviest elements in the universe, very, very, very one of the heaviest natural elements. And he got to wonder if that would accumulate on the surface of white dwarf stars. And he did some modeling and stuff like that. And what happens when you get a lot of uranium together, especially under high temperatures and pressures, you can get nuclear fusion. Fission, in the form of like what we uncontrolled nuclear fission, which is what we would call a nuclear bomb. So this was one of the first nuclear bombs we ever developed was by the fissile material of uranium. So could that build up? Could uranium build up? And could it cause supernovae of a type 1A? That's the kind of supernova that occur when a white dwarf does blow up. And these are also standard candles. We're going to talk about all of that during our hangout. So that is a brief intro to what this hangout is going to be about, the research that he's done, the modeling that he did, and what he found out about this possibility, which I think is really interesting. So that will be next week, same time. And so Nick, that's right. It's one step away from neutron degeneracy. So if you have a star that's larger than 10 solar masses, they tend to do what? Blow up. Supernova explosions, right? Anywhere from 10 to, I forget the upper range, but they're big. Supernova explosions. And when they blow up a star that's larger than 10 or 10 plus solar masses, they explode. The core collapses, the creating an uncontrolled explosion. And I'm going to do my hands like this because I have no visual graphics, so you're going to see a lot of this and this and this. I'm sitting here watching myself with the camera doing this stuff, and they leave behind the pressure from that leaves behind a core, a rapidly spinning core that is neutron degenerate, because when it collapses up to a certain solar mass, the core of that star bypasses the electron degeneracy stage. Because in a star like our sun, up to 10 solar masses, it collapses, but it can only go so far because there's not enough mass there. The electrons are strong enough to hold it up. In a supernova explosion, plus 10 solar masses, boom, the core collapses even further until now the neutrons are touching each other and holding the star up, the core up, and that's called a neutron star. We've heard about those, and they spin very rapidly, and when we detect those, they are pulsars. And if it is larger than some number, and I don't know it off the top of my head what that number is, from 10 solar masses up to, I don't know, let's say 30, then the neutrons won't be strong enough to hold it up, and it goes into a black hole. And these black holes are measured in stellar masses, and these are how stellar mass black holes are created. Supermassive black holes come from a bunch of stellar mass black holes, and on it goes. But yes, Nick, Chris, sorry, that is neutron degeneracy. For the win. Christian, how are you doing, man? It's good to see you. I'm glad you show up for my very occasional streams on YouTube. I've not done much on YouTube. Yeah. And that's true. It is one hell of a step, going from the electrons holding it up to the neutrons, and then finally to black holes. All of this has a lot of energy associated with it. So, so thank you. So yeah, that's very true. Yeah, still wondering about whether quark or color degeneracy comes into play at some point, dude. Yeah, I've never even heard of that, quark degeneracy. So a quark is a subatomic particle. Right now, we're talking about things like electrons and neutrons, and the degeneracy there, and that's just using atoms. Those are actually subatomic particles too, and they all make up atoms when they're all together. But then you're talking about, well, these quarks make up the subatomic particles. Can they be split apart and made degenerate? I would say no, because we don't see that anywhere. At least I don't think we do. And I'm no expert, and I'm just opining here. But when we go from a neutron degenerate core down to a black hole, that's the step, right? Maybe that's quark degeneracy in action, for all we know. It's hard to say. So, hey, Ann. It's good to see you. That's my sister, Ann. So yeah, it's good to see you too, Bill. Bill, Big Jordan, I call you Big Jordan, Big Norge, because I don't know if you want me to use your actual name. So anyway, sorry I'm coughing, and I'm sorry that we don't have a full actual hangout here. I will, and we could talk and maybe answer some questions if you want. Chris, I'll just put this out. Christian, I'll just put this out there. If I send you a link, you're welcome to join me and we can chat. But I don't know if you feel like doing that. It's amen, brother. It's turtles all the way down. Absolutely. Yeah, Christian's on YouTube. Maybe I shouldn't. I'm sitting here coughing. I probably shouldn't. So, quick JWST news. Did you guys hear? Because I did this on my T Cubed stream, but I haven't done it here on YouTube. JWST is folded up and it's ready. I'm laughing because I just don't believe it. It's ready to be packed up and sent and put in a rocket and launched. Can you believe it? JWST has folded its primary shield. Its primary, they're calling it a sun shield, not a heat shield, and it's been packed up for the final time. I think maybe they're going to deploy the primary one more time, but I think they've done that already. Anyway, we're getting there, folks. October of this year, 2021, the James Webb Space Telescope, after bajillions of years, I think species have evolved faster than this thing has been built. And so it's finally put together and almost ready for launch. They're going to put it on a barge and or a ship, and they're sending it to French Guiana. Now, NASA is being purposefully cagey about this because they don't want you to know when they're actually going to put this on a boat and send it to French Guiana. Why? And I'm not kidding when I say this, they're worried about pirates. Could you imagine? They put this thing on a barge and or a ship. I don't know which one it is. Last I heard it was a barge, but a barge seems kind of exposed to me. And they're worried pirates are going to take it. Now, this isn't unprecedented. It's happened in other space missions before where a chassis or something like that was delayed or taken to an alternate location, but it wasn't exactly piracy. But NASA is thinking about this. Now, if James Webb Space Telescope had any luck at all, it would be bad luck, right? So this is something they should probably take seriously, because if it's going to happen to any mission, it'll be this one, because my God. So so it's probably going to be uh, launched in October, so they say, and they're taking precautions, but they're not telling us exactly when they're going to ship it via the ocean. It's got to go through the Panama Canal, and I'm sure at some point somebody might notice it. But NASA has been pretty clandestine in the past when it has shipped its space telescopes. There was a story of an astronomer who happened to see a NASA truck on one of the interstates, and it turned out that all it had was a truck with a NASA logo on the door, and that turned out to be the Spitzer Space Telescope, where she had seen Spitzer being transferred down to Florida for launch. So they tend to not keep these as high priority or high visibility activities because of the vulnerability that all these spacecraft are in. So I get that. I don't know, man. What do you guys think? Is it going to launch? Hey, Galaxia. I was just telling everybody that Matt couldn't make. Matt is double booked today, so he's going to join me next Friday, and I'm sitting here blathering because I was already here. So, and I want to let you guys know that we are still on for this hangout. It's just going to be next week instead of today. So sorry about that. No, I don't have COVID, Mark. It's I'm still getting over the flu. My granddaughter got the flu and brought it over, and it really affected my lungs because when I was in the Army, I had pneumonia when I was in basic training, and ever since that time, every time I get any kind of flu, it really hits my lungs. So that's also why I've been super careful around COVID. I do not want COVID because if I get it, it's going to attack my lungs, and I'm already pretty damaged in my lungs from that pneumonia. So anyway, it lingers for weeks after I've had it. I was sick last week, which is why we didn't do the hangout last week, and we rescheduled for this week. And anyway, I've already told you that. So okay. So no, luckily it's not COVID cough. So boy, you guys just, it's like 10-15 after, and you guys are showing up. That's hey Dan, it's good to see you, man. Yeah, well, thanks, Galaxia. I mean, what else? I got the time. I thought we could spend it together. If you guys need to go somewhere else, I'll totally understand. So, oops, that's wrong. I went to click on. Oh, you guys are chatting now. The aliens control everything. Some are nice and some are evil. That's right. Some are nice and some are evil. So, oh, okay. Hang on just a sec. Let me send Christian the link, and we'll both chat at you. Hang on just a sec. This is going to be a restream link, Christian. So I'll send it via email. Oh wait, I got an email from Matt. Let me just take a look at that. Yeah. Okay. So yeah, Matt just confirmed that he's going to be here next week. So. All right. All right, Christian, I just emailed it to you. Christian, if you don't know, runs Launchpad Astronomy. He's got a website, or he's got his channel is his channel's going nuts. So if you aren't subscribed to him, you need to get that way. So demonic aliens and angelic aliens decide where you stand. That's right. I guess Stephen Hawking didn't think it was a good idea. Let's see. That's true. Launchpad Astronomy is on Discord too. He's got his own server, so definitely check that out. Oh, there he is. Hang on, let me get him in here. There you go.
Hey, how are you, Tony?
Hey, Christian. Thanks for joining. Yeah,
Of course.
Guys, let me know if you can hear him. I can hear him, but I don't know if
Yeah, please let me know if you can hear me. And this is what this is the stripped down, messed up, drugged out, not drugged out.
Well, I was drugged out last week. I'll tell you.
I bet you were.
I bet
you were. Yeah,
I was on a lot of stuff.
I'm glad that you're feeling better. But yeah, I haven't done my lighting or my hair or anything like that.
Oh, I never do that. I never do that anyway.
Yeah, but you're so damn handsome.
What is this? This isn't Kim Kardashian astronomy. We don't do
Oh no,
here.
But you're already so handsome. You don't need to do it. Me, I need all the effects and all that kind of stuff.
Yeah, accoutrement. So tell us what you're up to. How's it going?
It's going pretty well. Yeah, I mean,
your channel's blowing up.
Oh, thank you very much. It has been on the upswing. I just got to learn how to make videos more often. I tend to research these things to like the nth degree, and I just nerd out, and then I realize, oh yeah, I'm supposed to be making a video about this. So yeah, that's been my challenge, is just figuring out how do I get them turned around faster. And I hope someday I can get to the point where I can bring on some help, like people who know how to edit astronomy videos and things like that, as much as I love doing it. But anyway, what are you gonna do?
Yeah, it's well, and the more you do it, the more YouTube will reward you, because it's just you got to feed the beast, right?
Absolutely,
you got
absolutely.
You just keep feeding it,
without question.
Yeah, I just stopped being able to afford it. I had to actually earn money. So
yeah, well, that's the other thing too. Yeah,
so for me it was that. So, but yeah, it's well, you were doing. You do a lot of live streams now. You have a lot of.
I do some, yeah.
You do those in conjunction with Towson, right?
Right. So I do those. Yeah, in my day job, I teach at Towson University, where I am also the planetarium director, and I've given all of one planetarium show before we went into lockdown. So,
what does that mean? You were made the director, and then
yeah, I was made the director in January of last year. And I got to do the February show, and by March we were all sent home. We said, no, nobody comes back after spring break, and so that was that. So anyway, so I started doing these live shows in lieu of my planetarium show, and I'm starting to get the hang of it, and that's been a lot of fun as well. But I also enjoy making regular videos and just talking about this stuff. And actually, really, Tony, you were my earliest inspiration. I was like, oh, I want to grow up and be like him someday. So cool,
Well, yeah. Well, thank you. I don't know about. Yeah, I have screwed up so many times. I mean, my deep astronomy live streams have come synonymous with technical difficulties. If you go back and look at all of those, there's always something gone wrong with all of my live streams, and it's sometimes it's horrendous. Like somebody's mic will just be so bad you can't even hear them, or I can't get anybody to all show up at once, and so yeah.
Well, and one of my earliest live streams was the 24-hour-ish streamathon we did together with the Tomorrow TV channel
as well, for the Deep Horizons,
right?
The New Horizons
flyby, and that was epic. That was just a hoot and a holler. And then I just was like, I have no idea how to ever top that.
Yeah, that was a good opportunity because you were actually there at APL.
That's right.
So that was really cool that you could do that. So okay, so for those of you who don't know, I just got to talk about this for a minute. Planetaria are these things that existed for many decades in museums and school districts all over I love planetaria. My very first job was at the Clyde Tombaugh Planetarium in New Mexico. I worked at a school district planetarium when I was in high school. They are amazing things. And the fact that Towson has a planetarium to me is a testament to a good quality institution, because very few, they're not building them anymore. So I want to know, what's your planetarium like? What kind of projector do you have? How big's your dome?
Okay, well, actually, this is pretty cool. This is actually our university's second planetarium now, because we just got a brand new science building commissioned, and actually not commissioned, built. It's done. It's dusted. Well, it's getting dusted, and so what they've done is they basically built basically just an updated version of what we had. So I think the dome is like 24 feet across, if I remember correctly, and it's made by Spitz Systems, or Spitz Incorporated, and they're based out of Chadds Ford up in Pennsylvania. And it uses 2 4K projectors. Okay, so you have, it's basically, and I don't know how much you want to nerd out on the text here, but basically,
let's do it.
Yeah, it's their own bespoke version of Starry Night. If you're familiar with the Starry Night Planetarium software, it was actually it's made by, well, the original is made by Simulation Curriculum, but Spitz actually are making it under their own license just for their what's called Dome system. And so it basically pumps it through these 2 4K projectors. One in the south, one in the north, and it's on.
And they're blended.
And they have to be precisely aligned and calibrated, and all that kind of stuff. And it's really cool. I mean, they've done a really nice job, and the dome itself is really, really nice. This is an all new dome. It uses what they call the nano seam, so you don't see like little pinholes in them. And stuff like that.
Yeah. Ours had the pinholes. Did you? Is it tilted or is it flat?
Yeah, it's tilted. It's a tilted dome, so that's cool. It's going to save everyone's necks a little bit. Now, what they decided not to do, and a lot of these decisions were made before I was named director. In fact, all these decisions were made before I was named director. So you're gonna, if you come in and visit, I hope you do when all this is done. If you're fancy a trip,
I lived in Reisterstown, so I could have.
Troll stomping grounds.
I didn't know you there, so.
Oh yeah, no, exactly. We overlap. But anyway, my point is, if you or anybody watching ever stop by the show, you're going to be sitting on a wooden bench. Okay, so they deliberately did not go with like padded chairs, and the reason they didn't do that is because when they would try to teach classes in the old planetarium that has the nice comfy chairs, kids would fall asleep. And I thought to myself, well, that's just because you just didn't have a dynamically charming instructor. And then I realized,
exactly.
I'm not a dynamically charming instructor either. I guess I got to go with the benches then, if that's what it takes to keep them awake during classes.
So now they're doing this, sitting on a bench. That doesn't sound right.
Yeah, I mean, the bench has like a reclined back, so you're kind of like this. I mean, I don't know. We'll see how it goes. But so. Our fingers are crossed that we will be doing planetarium shows. I'm sorry, fingers are crossed that we'll be doing classes in person in the fall. And maybe, just maybe, we'll get to do planetarium shows as well. But obviously, we're going to have to see what the virus has to say.
I know.
When the time comes.
I get my second shot on Tuesday.
Oh, good.
I don't know. I hear it knocks you out. I'm getting the Moderna one, but
okay, I got the Pfizer's. Yeah, but I'm hoping to collect all 4. That's my goal. I want to get. Yeah.
Let's get 110% coverage there.
No, I got the Pfizer's, and I was a little bit woozy for about a day, but I was really fine after that.
Yeah. Okay. Well, I'll see how it goes. The reason Matt is double booked today is that he's getting his second shot today, and he was off by an hour, and because of the time difference, that's why he's not here right now.
Well, I'm happy to pinch hit.
Yeah. Yeah. So, so yeah.
Pinch hitting.
Yeah. So yeah, so Chris, the old pinhole projectors. I just wanted to. So back in my day, I grew up I came in on the 70s and the 80s. Now, what was popular in the 70s and 80s? Laser shows, right?
Yeah.
I worked at the Fisk Planetarium in the University of Colorado, and they had a 2-watt. At the time, this was a big deal. A 2-watt krypton argon laser, and they had a Zeiss projector, which was this giant behemoth that sat in the middle of the dome and had pinholes in it that were precisely registered and were projected in various quadrants out on the dome. And you could see things like the ecliptic and the galactic or the celestial sphere, and all these things would show on top of it. But it's funny, on Friday nights we always did The Dark Side of the Moon laser show. I know that album by complete heart. And
one of the best of all time.
Yeah. And the minute it started, the minute the very first song hits, you just started to smell. You just smell the pot, right? It was they were smoking in the planetarium there.
Starting to get a little dizzy and like, oh yeah, whoa, okay, yeah.
And then afterwards we would do a Star Talk, right? Well, by then everybody is a totally captive audience because they're just sitting there.
They're not
no matter what you show them, they're gonna love it, man.
They're cool,
like,
man. Yeah.
Oh, and now here's the Big Dipper, and you turn up the little Big Dipper thing, and they go, "Whoa!"
I can hear the Big Dipper.
Oh, that's amazing! And here is Orion. Oh man! So it's a great audience, man. You can just say anything, and they'd be like totally into it.
That's what I need. So, I need that.
Yeah. Now that it's getting legal everywhere.
I mean, it'll remind me of some of the. No, not yet. But that sounds like many of the Dead shows I used to go to. But well,
you know.
I'm familiar with that smell. Yeah.
Yeah.
So for those of you just joining, there are two astronomers talking about cannabis at Grateful Dead. Pink Floyd.
At Pink Floyd did laser shows. That's right.
We
didn't actually do them though. But secondhand smoke is very powerful.
You catch that, you definitely get it. So we're hoping to do that. Funny thing is, when I did my first planetarium show, I don't know any better than to just do like a pre-cam planetarium show. For like that one planetarium show, Beetlejuice was still in the news and it was having all that crazy stuff. So of course I just had to put together the most complicated, intricate planetarium show I could possibly think of while trying to learn the system. And it was like movies of like the star blowing up, and I had to figure out a way to make the constellation like Beetlejuice, like the star get really bright and then fade away and go to black. And it was a fun effect and it was a fun show. But you know what? I was actually working on it like right up until people were walking in. And as they were sitting down, I was just putting the finishing touches on. And I just went ahead and did it. And of course it crashed midway through. And so, I mean,
yeah, well,
like the computer system, like I was pushing I was pushing this new system to its limit, and I didn't realize I was going overboard with it. And but you know what, you live and learn, and it's a great deal of fun to just have those in-person opportunities. But this is definitely a close second. I mean, just getting a chance to talk with everybody, and so but there's quite a bit going on.
Yeah. How did that Beetlejuice story play out? I know that there was dimming and then it got bright again. So what did they actually, I haven't followed this in a while. So how did that actually play out? Is it understood now what's going on with it?
Well, okay. So there's basically, it depends on who you talk to. If you talk with certain researchers, and the names are escaping me, but that's probably best if I don't name names. But they're very convinced that what happened, it was a dust. It belched out a cloud of dust. Okay, so I mean, Betelgeuse is losing mass at a very prodigious rate. It's got these very powerful winds, and this stuff's initially coming out maybe kind of plasma-ish, but it very quickly cools to dust because, frankly, it's already kind of cool to begin with. It's in the outer angry cloud atmosphere of Betelgeuse, so it's coming out, and it cools and condenses in dust. And they suspect that what happened, one group of workers, and this is based upon they basically announced case closed on Betelgeuse, or it's settled, or what have you.
Right.
And that it was, in fact, this large cloud of dust obscuring Betelgeuse. And then as the dust it's kind of like moving kind of like this, if this is like our line of sight. So it's kind of like going like that. So Betelgeuse is coming back into, it's been brightening ever since, and that would explain why it's now back to like, I think it's like up to 90% of its standard brightness.
Right. Is it a gas cloud that is just in our line of sight, or is it gravitationally bound to Betelgeuse?
It's expelled away from Betelgeuse. It's going, it's leaving.
So Betelgeuse is the source of this cloud.
Yes, Betelgeuse is the source. Okay. So what happens that these these late stage red supergiants, I mean, we regard them as stars, and that's because they are still fusing something into something in their cores. We're not sure exactly where Betelgeuse is. We think it's probably in the helium burning phase, but in any event, it's still producing energy via nuclear fusion. However, the outer layers are so unstable and so cool that they eject off powerful stellar winds. And occasionally there'll be a convulsion, which will lead to a huge outflow of material, which quickly cools and condenses into dust. And that's this stuff that was thought to be blocking our line of sight. Now that is the primary, that one, like last year, there was a big news release on it, and it came out as this case closed. We figured this whole thing out, But, but remember that whole thing about Betelgeuse being an angry cloud? Well, it can also undergo very deep convections, and
it is a red supergiant, so it's a very active star.
Exactly, it's a very active star, and so this leads to another school of thought ironically, by one of the co-authors on the paper that promoted the dust hypothesis, that in fact there was no dust per se. It was just a super deep convection cell, and it can take up to a year or so to resolve itself and come back out and brighten again. So we still don't know for sure. It's still, there are different working theories. There obviously, what do? You take spectra, and sure, you do get a substantial blue shift, but can be explained by both models. You know what I mean? It could be the convection cell restoring itself, blue shift, or it could be dust, blue shift. So which is it? And the thing is that these stars don't really have, I mean, I think part of the problem is that these stars do not have well-defined edges like the sun does, or main sequence stars do. These are so distended that it's almost hard to know at first just where the star ends and the interstellar medium begins, that they're contributing to.
Yeah, and that's true even in our own system. We don't even, we're having a hard time with that. So.
Right, and then you take that problem that we have here, and then you magnify it, because you've got this very large star that's throwing out all of this tremendous amount of material all at once. And it really does become hard to tell. Oh yeah, and it's not like it does it uniformly either, right? It's like some of it goes off here, some of it goes off there, some of it goes in a different direction. One side of the star can do something while the other side of the star has no idea what's going on, because the sound waves take so long to travel. So yeah.
And Unknown Artist is asking, red giants, are those the ones who become supernovae?
Certainly can, yeah.
But
sometimes supernovae happen after the red giant phase. So like the red super, and really what we're talking about are the red supergiants, right? Because our sun will become a red giant, but it won't go supernova.
Yeah.
But you get these massive stars, and they go to just these red supergiants. But you know what? Then they can contract again, and they can become blue supergiants, and then they can expand again. And that's like with supernova 1987A, that was the progenitor, Sanduleak, whatever the star's name was, some license plate. It was a blue supergiant. And I remember when I was a kid, that blew me away, because I thought that only red supergiants went supernova. Now it turns out blue supergiants can go supernova as well.
Well, the deciding factors I talked about at the top of this stream is the mass, the mass of these stars. And for up to 10 solar masses, you get a star that probably will turn into a white dwarf, die much like our sun will, right? So expands into a red giant, sheds out its outer layers, leaves behind this white dwarf core. but anything bigger than that will probably hit. I don't know what the upper range is. Is it just 10 plus solar masses? It's a supernova.
I
think it's something like that.
Right. Like nature doesn't really, because I mean, it depends on other things too, like metallicities and other things. And frankly, there's just a lot that we don't yet fully understand. But it seems it seems like roughly somewhere in the 8 to 10-ish range is where you start seeing supernovae versus white dwarfs. And then of course, you can go into these very even higher mass stars, that like 40, 50, etc. solar masses, and they become hypernovae, like these supernovae.
Yeah, that's right. I remember those.
And those get pretty funky pretty quick, and gamma ray bursts and all kinds of fun stuff. Yeah, it's fun when stars die.
Yeah. So there's like these hyper what are they called? The hypernovae come from these like super large stars like VY Canis Majoris and those big type stars. And in fact, the earliest stars in the universe were probably a lot of stars like this, right? These were, I guess, what are they? Population 3. I never understood the classification, but it's not Pop 1, it's population 3.
Right.
And I think those were the first stars ever to shine, and they were incredibly large, and it only lived a few 100 million years. Blew up in these amazing hypernovae. So JWST once again will be the thing if it launches. That's going to.
I know. Where's the betting pool? I know.
What do you think? Is it gonna go in October?
Yeah, I do actually. For some strange reason, I think.
Can't bring myself to believe it.
It's on the barge, man. I mean, it's like. I mean, let me put.
Is it on the barge?
Well, I don't know, isn't it?
It's folded up. That was the last I heard.
Oh, okay.
And then the schedule went out the window because, like I said, NASA's
they're not gonna say. All right, so it's
Yeah.
presumably on the barge or heading to the. I guess the point is that if it's folded up, there's no more engineering to be done on it. There's no more fabrication, testing. So I guess
just a lot of nail biting at this point that you don't drop it. You know,
right? And I think that this is. I think realistically, barring anything, like it's hard to envision what the. I mean, wouldn't it have a fairly generous launch window if it's launching out to L2? Like, would that be like a wider launch window or a more narrow launch window?
No, I mean, I don't think it matters. L2 is L2, and it's not going to matter like where you are in the orbit around the sun. It's always going to be it's the Sun Earth L2 point. So
so the moon doesn't even.
The moon it's just 1.5 million miles out.
Okay,
or 1.5 million kilometers out, 1 million miles away. And I think they can go there anytime.
So I guess it's hard to know what kind of a delay would push the launch into 22. You know what I mean? Like unless there's something.
Well, one thing that concerns me is that it's going up on an Ariane 5, and they've decommissioned that already. Ariane Space has already moved on to the Ariane 6, and they've kept this one around, I guess, because that's what NASA had planned on using all along, and so they kept one available. And they've had fairing issues, right, where they're worried that when it launches, the fairing pressure inside of the payload area is going to damage the spacecraft. So they've put in special
I didn't know this
to reduce it. Yeah, to reduce this. So I mean, there's still there's only like 3,000 more things that can go wrong. I mean, if getting it to the rocket is not even the beginning of the sphincter inducing tightening. It's like we got 6 weeks it's going to take to deploy this thing, and as it goes out to the L2 point, I don't know, man. It's going to be a tense time.
But I guess in terms of your question, though, like, do we think it will still launch? Right? I mean, as far as at least blasting off on the 5. I mean, do you feel that that's likely to happen or not?
I can't bring myself to believe it.
I know. After all these years, there's got to be something else.
Oh, dude, I mean, we've been through it. I mean, you were probably working at the Institute when they were working on JWST, right?
Oh, yeah.
I mean, so
it was
I came and went.
Yeah.
NGST, that's right.
It was NGST at the time.
Yeah. And so
we're both Space Telescope Science Institute alumni that watched NGST, JWST not happen yet.
Yeah, exactly. We've both been. there was the excitement. It was like this at the Institute. It was just, boy,
Yeah.
we're gonna all this activity,
We're
and
gonna
then
have the second space no.
all these screws fell out. Oh
Yeah.
well, we're gonna now have to wait so then the activity would die down.
That's it. I quit.
Yeah. Well, people have moved on. I mean, there have been project scientists there that have worked on the project that have moved on. Jason Callery's now at JHU, and people that I worked with on the JWS. Alberto Conti, he went to Ball Aerospace. So all these people have come and gone, with the exception of, I think, the people at Goddard. I think John Mather is still the project scientist. John Ehrenberg at Northrop Grumman, who was the chief's engineer on it, I'm not so sure is. I saw him. Really? I think his LinkedIn page is listed as something else now, as his job description. So I don't know about that. But so people are coming and going, and that's an issue with astronomy programs like this, is that you just ask anybody who's worked on New Horizons, you conceive of these things, decades can go by before you see any science from any of this, right? And so you're hoping you're still working.
You're betting your whole career on one mission, and that may not be the smartest bet to ever make, for your whole career. So I see that. Captain Quinn says, with JWST, we have to dare amazing things. Well, that's absolutely. There is a question there. It looks like Galaxia was asking how many
Galaxia, how many solar masses was Betelgeuse as a main sequence star?
So we don't know for sure, but the estimates range anywhere from as low as 12 solar masses to as high as 25. It seems like most of the literature pins it somewhere around 19 solar masses, at least back in the day. Now it's lost weight since then because it's been throwing out a lot of mass. But yeah, that's the current consensus estimate, somewhere in the 19 solar mass neighborhood range. Take that for what it's worth.
Yeah, and the instability you were talking about earlier is point to this. It's also indicative of its life cycle, where it is. It's in its later part of it. That's why we're all thinking this could be a supernova at any time.
Now, speaking of supernovae or supernovae progenitors, and speaking of, well, not JWST, but Hubble, today is, of course, the 31st anniversary of the Hubble Space Telescope's launch.
1990!
1990! Oh my gosh, you're unbelievable. Maybe that was 91. Anyway, the point is that,
is today the anniversary?
Today's the anniversary. Oh, I'm sorry, tomorrow is. Tomorrow is. Tomorrow is the 24th.
Every year they release an anniversary picture,
and they released one today, and it's awesome. It is awesome. It's this. I don't know if you can bring it up, put it up on the screen or not, Tony, but it is the star AG Canarius, or AG Carinae rather, and it's a luminous blue variable star, which basically means it's a supernova progenitor. It's kind of like right there on the edge, and it's undergoing this just period of tremendous instability. And the great thing about this image, there it is. Isn't that beautiful, right? The great thing is that you've not only got the star, but Hubble can show us the nebulosity surrounding it, which really, frankly, is just the stuff that it threw out via its own expulsions of gas. Actually, I'm working on a video. I'm writing up to do a video about this because I just love, stars on the edge of going boom. But yeah, that's
So is this it right here?
This is it. That's AG Car. Mm-hmm.
Why can't I make it big? Go big in.
Oh, you know what? There you go.
Just hit this. I'll look at the full res.
Yeah. Beautiful. Look at that. And look at all of that activity. Now, there's no science paper associated with this. Usually when they do these press releases, they'll sometimes link to the relevant science paper. This is really just done because it's a pretty image. But oh my goodness, just look at that, to actually get to see that kind of intricate detail. And what's great about this is that you look and you see that there's kind of like it almost looks like there's a ring, right? It's almost like a donut surrounding the star. And what that's telling us is that there was actually, that's kind of like the history right there. So there was like this outflow of slower moving matter that it just blew out some time ago, like however many thousands or millions of years ago. And actually, no, it wouldn't be thousands. It wouldn't be millions of years ago. It would be in the thousands to tens of thousands of years ago. And then you had this faster wind. And it was probably not just a wind. It was probably more like a mini supernova, like this powerful outburst, you know. And so yeah, I mean, it's cool to see these things, because when this is an already very massive star, probably somewhere in the 30 to 60 solar mass range. So this is way more. This is probably much larger, more massive than even Betelgeuse. And it's having fits every now and again. It's in this really unstable period of its evolution.
Let's figure out how far away. Here you go. Unknown artist. It's 20,000 light years away inside our own Milky Way galaxy. So 20,000 light years away.
It really is beautiful. I agree with you.
Yeah, that's pretty. Well, these guys. I mean, they got Hubble to deal with. Also, it was taken in 3 pictures, or 3 filters. No, 4 filters.
Was it 4?
Wide field camera 3 and UViz.
Okay. Oh yeah. Okay. Right. So there's a UV. Okay, there's UV, green, yellow, and red. Yeah, nice. How many AU or someone does? Actually, that's a great question, Hans. The body of the main donut is something like 5 light years across. Now, just for scale, Alpha Centauri is 4 light years away, 4.3 light years away. So the Sun Alpha Centauri system, not that it is a system, but you know what I mean? It's that big. It's quite remarkable.
Well, here's a line right here. It says this is 3 light years, and so that would almost go across this whole thing. So
okay, you know what? You're right. That is a scale, and yet that conflicts with the press release that I read on. I think it was on spacetelescope.org. So will the real? Oh, you know what it is? I think 3 light years that's the correct scale, but I think that the outer nebulosity, which we probably aren't seeing because of the filters chosen, the way they process the image. That's my only guess.
Okay.
You know how these things are. If you load up like the FITS files and you start stretching with the gamma and stuff like that, you start playing with the dynamic range, you see all this other crap that you would never see because everything else gets washed out. That's just a pure guess on my part.
Well, part of this,
it's
yes. Big. Oh, what is it? Where'd it go? No, I don't want it down.
The red is ionized gas and the bluish white star light colliding to dust. So I learned from a video on ESA Hubble. Yeah.
So this might be this is UViz stuff. So this is UV then, the blue
right?
stuff.
That's got to be it. Yeah.
And by the way, guys, this is it for UV. Hubble is the only source of UV imaging anywhere, because you can't do this from the ground. And all the space telescopes that are either in orbit now or are being launched, JWST, is all infrared. So this is it. Once Hubble goes down, this ability to see these UV portions of these nebulae go away. We won't have it anymore until we launch. Maybe, I don't think WFIRST is going to have it, so it would have to be something like LUVOIR or whatever's coming down the road.
LUVOIR, actually, it's funny, of those future generation telescopes, I think LUVOIR was the only one that had any UV capability.
Yeah, so
unless the exoplanet, oh boy, it's I'm drawing a blank.
WFIRST?
No. It was there's 4 proposals. No, not Vera Rubin. I'm talking about the HabEx.
Yeah.
I think HabEx may or may not have some, and there's some talk about maybe combining HabEx with LUVOIR.
When are they going to decide that? By the way, I keep hearing about this decadal survey coming up, and yeah, you're right. There's 4. There's LUVOIR, HabEx, Atlas, I think is one, and then there's another one. Links, thank you. Yeah. The X-ray one.
X-ray.
When are they going to decide those?
22.
I've done hangouts, by the way, on all of these from people. Well,
next year is when the decadal survey is supposed to be published, and that's when they make the recommendation of which of these observatories, hopefully all 4, because honestly, the last decade. I mean, so here's the thing: like for anybody not sure what we're talking about, although I guess everybody here probably knows what you mean by decadal surveys. But, I mean, the 2000, the one that came out in 2002, recommended JWST. It was the formal recommendation. You know what? You know what the recommendation was of the 2012 decadal survey?
W first, wasn't it?
Yeah.
Yeah. But then they canceled it.
Yeah.
And then they came back with it after the NRO gave them those chassis. So,
but think about that just for a second. 10 years earlier, they were recommending this big ass, infrared telescope with the hex, folded up and all that kind of stuff. We're going to do this whole thing origami. We're going to something really big and ambitious. And then they said, yeah, let's just take like a 2.5 meter telescope or 2.4. Basically, it's like, don't get me wrong. I'm looking forward to W first. I really think it's going to be a fantastic instrument, but to make that to make that your flagship mission.
Yeah, it's still going to be. Well, hang on. I think JWST is going to be the flagship for quite a while.
No question.
But W first is going to launch. Is it early 2030s?
I think so. Yeah.
So it's going to go. JWST will probably still be up then.
Right.
For all we know, Hubble will still be up.
That'd be great. Yeah.
Yeah. Although it's looking pretty bad.
But my point is that W first to me felt like No. You want to be going this way, not this way.
Well, that's why I want LUVOIR, because that's
me too.
That's gonna dwarf JWST.
And I really hope that the lesson is learned by the decadal survey people, whoever puts these together, because they need to understand. And I think if I understand it, NASA's basically telling them, you got to go big. So it's like, go big or go home. In other words, if you want big things, if you want great things in astronomy, you have to ask for them. You have to make the case. This is why we need it. Put it into those decadal surveys, get it in front of Congress and say, we need this. This is science that is worthy of a civilization. And I think there's a reasonable chance that they'll say, yeah, okay.
Well, if you want my opinion on this, I think that NASA had better get JWST right. This has the ability to kill the science directorate at NASA if this thing fails.
Yeah.
So much is riding on this mission that if they can't pull off JWST, if anything goes wrong after all this, $9 billion, and it doesn't fly, I think that kills the science directorate. I think NASA will be like it was back in the Hubble days when they first launched, right? 1990 and 90 through 93, it was a mess, right? And it took a long time for NASA to recover. Now we all love Hubble, but it did not have those same beginnings. Everybody hated it. It was the butt of all jokes.
That's right.
And it had spherical aberration, for God's sake. So, I mean, that's like telescope making 101.
How do you get that right? How do you launch a telescope into space of any caliber with a misshapen mirror, and only the most expensive one ever launched at the time? And well, at the same time, and again, I'm not saying JWST doesn't have like a trillion failure points. It certainly does, but that is one of the advantages, I guess, of going with the hexagons, right? You can change the shape of the mirror, by phasing them differently. But
right, that probably won't happen again. In this case, it'll be probably that damn sun shield. It'll be the thing that kills this thing, because it's got to get down to 34 Kelvin or it won't work. So so it's it's going to be nail biting time for sure.
Yes, it is.
All righty. Well, gosh, I want to listen, man. It's good talking to you, by the way.
You too, my friend.
Thanks for showing up, and thanks for helping me out with this stream. I do appreciate it. And so I mean, I've got to record a Space Junk podcast here in about 20 minutes. So if you guys aren't listening to Space Junk podcast, please do. That's my main effort right now in science communication. It's available on Spotify, iTunes, all of it. My co-host Dustin Gibson from OPT joins me, and we are going to be talking tonight about automation. What gear can you buy to automate your personal observatory? So that's going to be tonight. Please subscribe to the podcast if you don't already. And I want to thank you, Hans, for the support and the super chat. Thank you, man. I do appreciate this help. And if you haven't, Christian Reddy, Launchpad Astronomy. If you don't subscribe to him, go over there right now. The link is in my channel, but not in this particular video because I wasn't expecting him. But if you go to my channel and you can click on Launchpad Astronomy, go subscribe to him. He's doing an awesome job. You really are, by the way. I love your videos. I love the way even though it's taking you time, it shows, right? I mean, that's how you know you care about what you're doing. It's the quality of your videos are very good.
Thank you.
So
thank you very much.
Well done. And so check out his videos. All right. I guess I'm going to go ahead and end the stream. I want to thank you all. I'm going to go ahead and hit the off-air button for you.
Okay.
Okay. So
bye.
Thank you very much, Christian. Okay, guys, that's it for me. I am out of here. I want to thank you all so much for watching. And always remember, don't ever forget, the best part of waking up is Folgers in your cup. That's a joke. I used to do keep looking up, but now I say that because Tony's Twitch Tuesday. Please check me out on that. Tuesdays, 3 o'clock Eastern. We'll chat on Twitch every week if you want to. And this hangout will be back the next Friday, 3 o'clock. And this time, Matt will be with me. So thank you all for your patience. Thank you for joining and for sending me questions and having a nice chat. Have a great weekend, everybody. Talk to you later. And as always, I'll go ahead and do it. Keep looking up.